Today, we will talk about how to navigate the most common threats in AI-based systems. In recent years, we have all witnessed an explosive growth of generative AI tools. They promise to have an unprecedented impact on our society, and virtually everybody is looking into AI and Gen AI. Now, with the increased development of AI and Gen AI-based tools, the associated security risk also increases. As it is usually the case with emerging technology, widespread adoption progresses faster than our understanding of their security. The journey in new technology starts with usage first, then followed by formulation of security guidelines and regulations. Once regulation is in place, we can develop and implement safe solution in a secure way. And the period between usage and secure implementation is a period of increased risk. I believe that we are somewhere here. We are still discovering all the security issues, and we are still in the process of having regulation in place for protecting us. Today, we will first discuss some typical threats that AI-based applications are exposed to. Then we will look into how to identify security threats and mitigations in the space of AI. We will finish with concluding remarks and the Q&A session. You can post your question anytime using the Q&A tab. You can also vote the questions that are posted, and after the presentation, we will go through them in that order. If we won't have time to answer the questions, we will follow up by email afterwards. Also to mention that the slides and recordings will be shared tomorrow. So just quickly introduce who we are. My name is Zadui. I am Senior Security Architect at Alexandra Institute. Today with me later on will join Panos from PrivacyMate, a startup offering an AI agent for automating compliance workflows called HipEcho. And Panos will share his experience with the threat modeling framework specifically designed for agentic AI that we will talk about today. The knowledge we'll present today was developed in the project Security by Design for AI Startups, Secure and Scalable AI Agents, where we at the Alexandra Institute investigated several aspects of security challenges faced by AI startups. And we did this in a collaboration with HipEcho. Very quickly, who the Alexandra Institute is. It is a research and technology organization. We are approved by the Danish Ministry of Higher Education and Science. We help organizations use and adapt new digital technology, and we do it by taking the latest research from academia and translating it into something that can be used and applied in the industrial world. So to say, we build the bridge between academia and industry. We have 4 different areas of focus, including artificial intelligence and cybersecurity. And today we couple both of these areas, and we will talk about AI security. Before we move to the content, let me ask a question to get to know the audience a bit better. So I would like to know, is your company developing or using AI-based application? A poll should appear now on your screens. Please take a second to vote. And I can see already some responses coming. You can also pick multiple, for example, if your company both developing and using, so you can pick multiple choices as well. I can see some responses coming. I can see that we have little more people whose company is using AI and not developing, but they are almost the same, and there are a few that neither. Thank you very much for your replies. So we have almost the using and developing equally. Good. So let's move on now and let's start by looking into some concrete security issues that arises when AI enters the picture. Prompt injection. Prompt injection is considered the top security challenge for AI-based application. It is an attack against application built on top of large language models, where an attacker feeds hidden, malicious, or manipulative instruction to alter the LLM's behavior. Prompt injection exploits the fact that LLM doesn't distinguish between trusted developers' instructions and untrusted user input. So the LLM treats any input equally and doesn't know the source. It is hard to protect against prompt injection, and it is very much an arms race between Agnosis attackers and their ability to construct clever injections and the developer's ability to harden their LLM. Let's look at two types of injection and discuss some of the challenges and solutions. Direct prompt injection. In this case, the attacker is directly feeding the prompt to the LLM with instructions to try to bypass any filters or restrictions that the bot has. The goal is to get around the developer's system-level rules. For example, asking the bot to ignore original engineer's instruction and disclose the system prompts, as shown in the picture. This attack can lead to sensitive information disclosure or make the bot act on behalf of the attacker. Indirect prompt injection, another type of prompt injection. In this case, the attacker is not interacting directly with the LLM, but poisoning an input that might be fed to the LLM. For instance, if I know that a company is using an AI algorithm to analyze CVs, I can pass to them a CV that is enriched with text that will be visible to the machine, but not to the human recruiters. In this way, I'm engineering the prompt to obtain an illegal advantage and be ranked above other candidates. While it might sound theoretical, there are existing websites that do this type of enrichment to file. One of these websites is shown down in the slide. Indirect prompt injection can lead, for example, to data exfiltration, data poisoning, or remote code execution. Another common scenario of indirect prompt injection is when an attacker puts hidden instructions or populates misinformation in external data sources, such as the web, which an AI system then reads and acts on, for instance, when summarizing a web page. Just to give you a simple real-world example of this attack. A few days ago, a BBC reporter stated that he managed to hack ChatGPT and Google's AI within a short time. So what he did, he wrote an article on his personal web entitled "The Best Tech Journalist at Eating Hot Dogs," where every word was a lie. He claimed, without evidence, that competitive hot dog eating is a popular hobby among tech reporters, and based his ranking on the 2026 South Dakota International Hot Dog Championship, which doesn't exist. He ranked himself number 1, obviously. Then he listed a few fake reporters and real journalists who gave him permission. After that, he turned to popular AI engines and he asked Gemini, AI Overview, and ChatGPT about the best hot dog eating tech journalist. And all gave the fake response. You can see the Gemini's response on the slide. And this is a simple example that shows that these attacks are real and even big players can be subject to them. By the way, at least Gemini already knows about this scam. I checked it, you can see that. screenshot for my question. So mitigating these attacks is not a straightforward task. However, here are some mitigations to strengthen the LLM's resilience to attacks. First, user input is the most common attack vector, so it requires strict validation. Second, restrict the structure of AI responses makes it harder for attackers to change the model's behavior with injected prompts. So, you need to create predefined templates for the outputs and set formatting rules. Avoid open-ended outputs for high-risk application, if possible. Third, implement human-in-the-loop functionality. This means requiring a human to approve any action that could be harmful, such as sending email or deleting file. Fourth, you should not grant LLMs unrestricted access to your data and system in general. Configure API permissions to essential functions and store tokens outside the model's search. As always in security, logging and monitoring is key to detect and block attacks. While these prompts can be extremely difficult to detect, it could be worthwhile to construct anomaly detection pattern recognition methods to look for known injection patterns. And last but not least, you can strengthen your AI's resilience by training models on adversarial examples. Fine-tune the model with real-world attack scenarios and equip the system with classifiers to detect suspicious prompts faster. Another attack I would like to discuss today is excessive agency. What is it? LLM-based systems are often granted a degree of agency. And when we give the system more access or autonomy than necessary, this can create serious operational and security risks. There are three types of excessive agency. Excessive functionality is then, for example, an LLM agent having access to plugins where the functionalities are not granular enough and scoped exactly to the intended use case. Excessive permission is then an LLM plugin that doesn't comply with the rule of least privileges. For example, providing write access when only read is required. And excessive autonomy is then, for example, a LLM application performs potentially damaging actions automatically poorly based on its interpretation of input without any interaction with the user. Let's look into an example, so to understand the attack better. Consider an LLM-powered personal assistant that has been granted access to an individual's mailbox to summarize the content of incoming emails. In this example, the system is enhanced with a plugin to fetch email, so that the LLM can answer the prompt, summarize today's email. For this to work, either the bot, the application, or the plugin should be granted access to a specific mailbox and the ability to perform. So that then user sends a prompt, summarize today's email, then the application, calling the corresponding plugin, can fetch emails from the mailbox, return to the bot generates a summary and sends a response back to the user, as shown on a picture. Now, assume that the plugin has not only the ability to read, but also to send emails. Malicious content from an attacker might include a prompt designed to send email, for example, for spam purposes or share information with the attacker, some sensitive information. In this way, the flow will trigger the LLM bot to instruct the plugin to send email, while still responding with the intended output to the original user prompt. This explores excessive functionality and permissions. The flow is designed to allow the user to get an email summary, but actually it allows to perform more than that because of the excessive functionality and permission. So let's look at the flow, focusing on the malicious behavior. So assuming that an attacker sends an email including a malicious prompt. Now a user sends a prompt, summarize today's email. Bot, again calling the plugin, fetches the emails from the mailbox, including also malicious email, returns to the bot. Bot generates a summary, sends a response to the email, meanwhile also performing the prompt, for example, sending some sensitive information to the attacker. So in this example, the LLM is vulnerable to an indirect prompt injection attack, whereby a maliciously crafted incoming email tricks the LLM into sending spam message from the user's mailbox. This could be avoided by granting the LLM read-only access to the mailbox and not the ability to send messages, or by requiring the user to manually review and hit send every mail drafted by the LLM. Let's look into some mitigations for excessive agency. First, limit the functions that are implemented in the LLM extensions, such as plugins and tools, to the minimum necessary. For example, a plugin that accesses a user's mailbox to summarize emails may only require the ability to read emails. So the plugin should not contain other functionality such as sending or deleting messages, like in the example above. Second, limit the plugin or tools that LLM agents are allowed to call to only the minimum functions necessary. For example, if an LLM-based system doesn't require the ability to fetch the content of a URL, then such a plugin should not be offered to the LLM agents. Third, avoid open-ended functions where possible. For example, run a shell command, fetch a URL, and others. And use plugins and tools with more granular functionality. For example, an LLM-based application may need to write some output to a file. If these were implemented using a plugin to run a shell function, then the scope for undescribed actions is very large. A more secure alternative will be a build file writing plugin that could only support that specific functionality. Fourth, limit the permission that LLM extensions are granted to other systems to the minimum necessary in order to limit the scope of undesirable actions. Similar to the prompt injections, require human approval for high-impact actions before they are taken. For example, sending an email. And same as prompt injection, detect and prevent by logging and monitoring the activities of plugins and tools. Now, we have seen a few examples of AI-specific security issues and discussed some concrete mitigations for each attack. But how do we go about identifying all AI-related security threats and discussing corresponding mitigations? Threat modeling can help us here. First of all, threat modeling brings some benefits to the table that are not specific to AI cases. It helps us identify risk and reason about the corresponding mitigations. And it does this whilst keeping in mind cost consideration. Threat modeling works with any type of risk, whether they be attacks or just failures. And it is great aid in a compliance and standardization journey, and mandatory in some industries as well. Before we move to the threat modeling, let me ask another question as well. How familiar are you with the threat modeling? And I launch. A poll should appear now on your screen as well, so please take a second to vote. I can see some responses already coming. Okay. Nice. Oh, good. Okay. Responses are mixed. We have some people who are very familiar, somewhat familiar, and there are some who are not familiar at all. Okay, good. We have all. Thank you for your response. So I will give some introduction to the threat modeling as well. So who are not familiar will get introduction. Who are very familiar might already know this. But let's look into threat modeling, which is part of the wider risk management process. And ISO 27005 is our reference for cybersecurity risk management. And this high-level picture that you can see on the slide is built on that. At high level, a few words about risk management before we go into the threat modeling. The risk management process starts with establishing the context of the assessment. This allows then to model the system components and their interaction, identify the important assets for the system, and then perform threat modeling. And note that this is a good practice to run risk assessment and review previous outcomes regular. Risk assessment, also threat modeling, is not one-time activity. It is advised to do it at least once a year. Now, let's look into the threat modeling steps a little more detail. So, first step in threat modeling, we start identifying security threats based on the previous step, having a system model and identify asset, we identify security threats. Then we move on into analyzing these threats. We are estimating likelihood and impact for each threat, and based on these two values, we calculate risk score for each threat. This allows us to order the threats based on risk score and evaluate the risks. And then we are identifying what needs to be improved by evaluating scores for each threat and focusing on the subset of the threats. We are identifying mitigation and planning the implementation of mitigations. Quick steps of the threat modeling. Now, while the process of threat modeling does not really change when talking about AI, what is potentially new is the set of attacks made possible by AI or accelerated when targeting AI system. Traditional threat modeling methods such as CIA or STRIDE lack the necessary scope to address AI-specific threats. Hence, a new method is needed to address these attacks and consider these dynamic behavioral, learning feedback loops, and probabilistic outcomes of AI applications. There are few emerging frameworks tailored for AI system, such as Meteor Atlas and the agentic AI threat modeling framework Maestro. And today we will look into the Maestro framework a little more. Maestro stands for Multi-Agent Environment, Security, Threat, Risk, and Outcome. The framework is created by the Cloud Security Alliance, which is a non-profit organization committed to awareness, implementation, and credentialing of AI, cloud, and zero trust. The framework is specifically designed for AI, for an agentic AI system, and it is particularly useful for LLMs and generative AI agents with decision-making capabilities. The framework considers 7 distinct architectural layers presented in the picture. These layers range from foundational models at the core, layer 1, through data operations, agents framework, and deployment infrastructure, all the way up to the agent ecosystem where real business values is delivered. Each layer abstracts complexity from the lower layer, enabling modular development and systematic implementation. Let's look into some threat examples at a different layer, so it's not so much theoretical. Consider the prompt injection attack that I presented earlier. One thing is to protect against prompt injection in general. Another thing is to protect against the specific consequences of successful prompt injection. And by reasoning on Maestro framework, we can understand how prompt injection can lead to different consequences and identify mitigation for each case accordingly. For example, in the second layer, data operation, prompt injection can lead to exfiltrating data or poisoning data. Or in layer 4, agent frameworks, an attacker using prompt injection can trick the agent into misusing its tools in the agent environment. Another example, if we look into layer 6, security and compliance, attacker can use indirect prompt injection to modify processing objectives, and those lead to intended breaking and goal manipulation. So how to use Maestro framework? Well, Maestro is essentially a threat modeling framework. And as any such framework, it defines a series of steps to go through for identifying threats and countermeasures, similar what I show a few slides above the steps. So we start by decomposing the system into components, then model threats for each layer, as we saw earlier, as well as across layers. And finally, we move to standard threat modeling steps for assessing the risks with the likelihood and impact, identifying mitigations, and planning the implementation. In other words, what is specific to Maestro is the layered model and the threat modeling conducted layer by layer to capture AI-specific threats. Moreover, the framework is supported by AI-enabled tool, which automates layer-specific and cross-layer threat identification and mitigation planning steps, these 3 steps. Let's look into the tool. Here is the Maestro Threat Analysis Tools interface. It is an AI-enabled tool that uses LLMs via GenKit, including Google Gemini, OpenAI, and Ollama model. So we can pick which model we want to provide. In order for use this tool, first we need to give the description of architecture. You can see here, let me see if you can see here. There is this is a fill-in example model. Then we write in a text the architecture description, and more detailed description we write, more precise AI threats the tool provides us. And then in the by second arrow here, we are creating generate analysis, and the tool generates threat analysis and provides also mitigation strategies based on the Maestro framework. The tool is open source and still under development, so do not expect a full-fledged commercial product. So when we click the generate analysis, then the outcome, it's identify threats for each layer. So as you can see in the screen, for each layer, the tool is identifying threats, and here including both AI-specific as well as non-AI-specific threats, and also providing some mitigation strategy. And as I mentioned earlier, more detailed description about our architecture we provide, more precise are the identified threats as well. So yeah, that is this correlation there. Now, together with 2 startups, we try both Maestro framework as well as a Maestro tool. And today we have with us one representative of one of startups. Yes, Panos, who will share his experience of using this tool. So first of all, Panos, if you can just say a few words about you and Hipeco.
Yes, thank you, Zara. Very interesting talk. So my name is Panos, and I'm one of the co-founders of Hypaco, where what we basically do is we're implementing an agent that works across different compliance fields, and we target compliance professionals specifically in cybersecurity and privacy legislation. So our target user is usually a lawyer or an in-house resource which deals with the compliance workflows of the company. Yeah, that's me.
Thank you. Now, if we can talk a little your experience with Maestro framework together, we carry out a workshop, threat modeling workshop, where we
Yes.
looked into this Maestro framework. Can you say a few words?
Mm-hmm. Yes, absolutely. I'll start first by saying that my background is also in cyber, so I'm quite familiar with threat modeling as a process in general. I've done it in various forms and shapes, from using a framework, following it step by step, to actually doing more of a discussion kind of exercise. So I was familiar with that, and we do threat modeling as an exercise for our product as well whenever we have a big product release specifically. And that's very important because we work with different platforms. So we have a browser extension, we have a Word add-in, we have a web application. So it's very important to us to understand the different threat across those different platforms. So Maestro, I think the most useful thing that made it for us during this collaboration that we did in this project that we did together with you, Zara, and the other guys at Alexander, was that we got familiar with a lot of the threats on AI. And I think it's very useful the way that they've structured the framework with those layers. Because once you start going through that, you will see that a lot of layers that don't apply to you. For instance, if you don't develop machine learning models from scratch, LLMs or any kind of machine learning model, the first layers in the beginning, they will probably not apply to you. So it helps you like filter out what is not relevant and focus on the things that are relevant for you. So for us, because we're a very small team, that was very helpful. But it can also become like very overwhelming in the beginning when you try to follow a framework step by step. So that's also gonna be like my advice for anyone who's gonna try it, go through it, like get familiar with the attacks and the different concept when it comes to securing those systems and how to frame risk, etc. But you may have to start much simpler, with just having a conversation between you and the team, have like draw the architecture diagrams on a whiteboard or somewhere, wherever you have it in a tool, and then start discussing, okay, what are the most important use cases for us when it comes to AI, and what can go wrong and what can we do about it. And that's basically it. And then if you think that you have time to do more and more, like, you can go and follow the framework step by step. But the ones that they build the framework as well, they don't expect you to work like that. So that's about the framework, I would say. And then the tool is also like helpful to get to know a lot of those threats. So you give, as you showed, you give the description of your product, And the more detailed this description is, the better threads that you're gonna get as an output. I think what I was missing from the tool was things like, if you could upload the description of your product through a document, because you would have this description somewhere, instead of you having to copy paste it, or there were some limitations around how big the description could be. I think it was like 5,000 characters or something, 5,000 words. So there could be some improvements there. But again, it's a tool that can help you like get started with it, and then you can, I think, either find something which is more specific, or find a commercial tool, or go on and extend this tool by yourself. So I think it gives you the idea of what you can do and how you can work with that. Yeah. So
thank you. Yes. And I think just to add, so we worked with this frameworks and tool with another startup as well, and just to bring their views as well, because as you mentioned, Panos, you had background in cybersecurity, so
yeah.
A lot of things, it was a little easy, while the developer in the other startup, he didn't have that. So when we carry on the workshop, a lot of things for him also was new to learn and to understand. And as you mentioned, that some layers you see that, oh, this is not fitting for me. It was also with the other startups as well, that we went, we looked into different threads, but we identify, okay, this matching, this not, because the framework is focused on multi-agent AI system, and which was not exactly neither your case nor the other startups' case. However, it helped also just to bring up for the other startups. They were thinking about some functionalities to add in their system, and this thread modeling framework helped them to understand what are the risks to that functionality. Can they take care of that risk and implement or no? So this is another also point that thread modeling can help. For my own experience, I can say that I agree. The framework of Maestro framework is good start, but it's not so basic. And as you said, it's nice point to start with something small and then build on top, so that you don't get overwhelmed. And the same with the tool as well. Yes, I agree. It's nice to get this thread that you can start, but of course there is, better description you give, better threads you get. Otherwise, the threads might end up being a little more generic. Anyway, I mean, correct me if I'm wrong. I think it's still a good framework and tool just to help start and get also idea about some threads, because that might be difficult to talk. Okay, what are the AI threads out there?
Yeah, and again, this layered approach helps a lot, because with this new type of technology, it's also hard sometimes to say, okay, does this threat apply to me? Does it apply to the model provider that I'm using? I'm using an API from Google, from OpenAI, or whatever, or where should I focus? Because at the end of the day, we all need to balance the time that we spend on security and building, right? Or talking to customers, or all those things that we have to do. You don't have unlimited time to go through all of that. So the layered approach and the structure that they provided actually helps a lot. And I think it really was like, at least like going through it to see how all those people like have worked on this framework, and what are their thoughts about the different attacks that exist out there, and then adjust to your specific case.
Yeah, that's true. And the still emerging fields, they are few, but hopefully they will be much more focusing on different. This framework specifically focused on AI agents.
Yeah.
Then there is, of course, Meteor Atlas, if companies are already using Meter, so that is another one, and hopefully we will see that there are more frameworks coming that can help.
Yeah,
Yes.
absolutely. Yeah.
Thank you. Thank you for sharing.
Thank you, Zara.
Now let's look at some of the questions and try to answer the questions if they are. Just last point for me, you can get in touch with us if you need support on your AI security journey. There is a link that you can contact. I can see that we have one question for now. If you have any question, feel free to write. We still have a few minutes. So the question is, what was the ISO standard you mentioned in risk management AI threat modeling? It's ISO 27005, the ISO standard that we are referring to. If you have any more questions, just ask, or otherwise it seems that we did a great job. Everything is clear. You are also, of course, welcome to ask any questions later on, sending email or contacting us. Okay, I can't see any more questions coming. Then I will thank Panos and I will thank everyone for joining. The slides and recordings will be shared tomorrow. Thank you. Have a nice day, everyone.
Thanks a lot. Have a good day.
Bye.